differentiation to find dy dx. I want to find the second derivative with notation d squared y over dx squared. This means second derivative. I gotta get the first derivative before I can find the second derivative. So what's the derivative of x squared minus y squared equals 20? Term by term. Heard 2x to start, cool.
Minus 2y, dy dx.
Equals nothing. Let's solve for dy dx. Negative 2y dy dx equals negative 2x when I slide that term over to the right side of the equation. Then divide everything by negative 2y. So dy dx equals negative 2x divided by negative 2y, which reduces down to, what is that, positive x over y? Well, we're looking good here. Let's keep moving. I got to differentiate the first derivative to find the second derivative. So let's take the derivative of x over y. Once I differentiate x over y, I'll have the second derivative. How do I take the derivative of x divided by y? Quotient rule, right, Kim? I can't just do derivative of top and derivative of bottom. I have to do quotient rule. So low d high minus high d low all over low squared. So low would be y times d high, which would be derivative of x, or just 1. Minus high, which is x, times d low, which is dy dx, all over low squared, so y squared. So the second derivative of y with respect to x equals y minus x times dy dx over y squared. Here's where we're at so far. Does anybody see anything a little bit alarming about where we're at so far?
Fraction.
Sure, fraction and fraction. What else? I can't cancel out this term and this term without also canceling out something from this term. It's got to be from all three. Okay, I like that train of thought. Isn't it kind of weird to have the second derivative in terms of x and y and the first derivative? My second derivative is also in terms of the first derivative. But what is dy dx really equal to? Didn't we kind of see that over here already? So let's just take x over y and substitute it in for dy dx, because that's what dy dx is equal to in terms of x and y. Replace dy dx with x over y, and now at least I have it in terms of just x and y for my second derivative. See, I might multiply everything by y to get this a little bit cleaned up. To get rid of that extra fraction that somebody mentioned earlier. Multiplying by y and dividing by y at the same time cancels out. So that leaves me with d squared y over dx squared equal to y squared minus x squared over y cubed. We're getting real close. There is technically one last thing I can do to simplify. What is y squared minus x squared equal to? Not an identity, it's somewhere up on the board here. Y squared minus x squared is equal to some value. Close. X squared minus y squared, Luke, is equal to 20. I have y squared minus x squared. How can I make x squared minus y squared look more like y squared minus x squared? What's the difference between this and this?
This one.
Just flip the signs, right? Multiply everything by -1, flip the signs. X squared is negative x squared down here. Negative y squared is positive y squared down here. So aren't the signs just exactly the opposite? If x squared minus y squared is 20, that implies that y squared minus x squared equals -20. So I can also resubstitute the original equation back for the second derivative. I had to replace dy dx with x over y. That left me a form similar to the original function that I can also substitute back with and simplify further. Y squared minus x squared is the same as -20. So altogether, -20 over y cubed. Final form of the second derivative. -20 over y to the third. Let's try one more. They're all a little bit different. So let's get a couple good examples of finding second derivatives, higher order derivatives with implicit differentiation. I have one in here. 1 minus xy equals x minus y. Just this. That glare is right there. Can you guys see that okay? I know there's a glare right there. I've got 1 minus xy equals x minus y. Do my best to kind of try and frame it, but there's a glare right there. All right, let's go ahead and start finding the derivative. Find the first derivative before I can get to the second derivative. What's the derivative of 1? 0. How do I find the derivative of negative xy? Product rule. Let's think of this negative x as being the first part of that product that I'll use product rule for, and y being the second part of that product. If you post rule, product rule is first times the derivative of the second plus the second times the derivative of the first. So the first, which would be negative x, times the derivative of the second, or dy dx, plus the second times the derivative of the first. Second would be y. The derivative of the first, negative x, would be -1. So there's the product rule form of the derivative of negative xy. Negative x dy dx minus y. Equal to, on the right, what's the derivative of x minus y? Second, Caitlin?
Oh.
I think you said.
1 minus dy.
Got it. Negative x dy dx minus y equals 1 minus dy dx. I suppose this is good practice on finding the first derivative using implicit differentiation. Where do we go from here? Well, I gotta find dy dx first. I don't have dy dx solved for. I don't know what the first derivative is yet.
Add.
So you're saying like, get like the x's and the y's and the dy dx is all kind of grouped together? Let's maybe move this negative dy dx over to the left, and I'll move the negative y by adding it over to the right. So now each of the two terms that have dy dx would be on the same side. Gesundheit. And the two terms that do not are on the other side. Okay, factor out of dy dx. And now I can divide to find the final first derivative. The first derivative of y, dy dx equals 1 plus y, or 1 minus x. What's next? Quotient rule to find the second derivative. Low d high minus high d low, all over low squared. So this will now be the second derivative once I apply quotient. Quantity 1 minus x. D high, what's the derivative of 1 plus y? Try this one, Cheney. What's the derivative of 1 plus y?
It would be dy.
Correct. Derivative of 1, forget about it. Derivative of y, dy dx, like you said. Minus high, 1 plus y, times d low. What's the derivative of 1 minus x?
Negative
1. All over quantity 1 minus x squared. Remember my advice to you before I did this. What do I have to back substitute to keep simplifying? Right. Look at my second derivative so far. It's in terms of x and y and the first derivative. It's kind of weird to have the second derivative also be in terms of the first derivative. So let's take 1 plus y over 1 minus x and just substitute it back in for dy dx to simplify that down further. So 1 minus x times 1 plus y over 1 minus x. See, these are both double negatives. So this should still just be plus 1 plus y. Right? Because this negative 1 cancels out this negative 1. Yeah. Over quantity 1 minus x squared. Getting closer. At least I have dy dx back substituted and replaced. How can I keep simplifying? Wouldn't 1 minus x's just cancel? I'm both dividing by 1 minus x and multiplying by 1 minus x. Almost there. 1 plus y from here, plus 1 plus y from here, all over quantity 1 minus x squared. Combine the like terms on top. I think I see 2 plus 2y over quantity 1 minus x squared. That is what we need. Plus 2y over quantity 1 minus x squared. Questions on those? Okay, let's do this one. I'll put one on the back wall for you. Then we'll finish up some practice. Let's do this. Let's do like. Hunter, Lily, how we doing, guys?
I'm doing pretty good.
All right. Let me wheel you here, and I'll show you what we got so far. I just give everyone this one in class to practice, and then we'll pull up some extra work on Schoology, okay? Probably a quiz early next week after we come back from turkey break. Find the second derivative of y cubed equals 10x using implicit differentiation. I think I got negative 200 over 9y to the fifth. We'll see if that looks right. Find the first derivative, then find the second derivative. Don't forget the back substitute to simplify your answer. Negative 10 times 6y is minus x. Let's see here. What's 6 divided by 3? 2. So it's negative 10 times 2 times 10. A lot of times y squared is 1 cubed. Really, the y squared is unlocked. So we have negative 200 over y divided by 9y to the fourth. Yeah.
Just answer.
So we'll start this down so far. So you're just about there. So you've got negative 200 over y over 9y. What do you do with the last y?
How'd you get the 9?
3 squared.
Oh,
Yeah, 3y squared times 3y squared is 9y.
where did you get 200? You'll have to get that back and you times by y.
So it's just negative 200 over 9y. Okay. You can do the first derivative. You just have to do the second derivative and then also back substitute. Answer should be negative 200 over 9y to the fifth. If that's not looking right, let me know. What's up? Got the first derivative, right? You comfortable. Low D high. I think you looks like. Ooh, no, it's 3y squared times d high, which is the 10. Oh, wait, no, okay, you didn't listen. You just started that like this here. Yeah, so you have negative 10 times 6y times dy dx. But what is dy dx equal to? You gotta back substitute this in. Someone come in? Yeah. Like there's, I'm sorry, Jane, what's up?
So I think I found the first derivative, is that,
Yeah, this is perfect.
and then I don't know, I like messed up the second part.
Well, this looks fine,
Is that-
but what is dy dx equal to? You need to back substitute and replace dy dx with 10 over 3y squared.
Wait, so what do you?
You see how we plug this in? I replaced dy dx with what it was equal to from the first derivative. Do the same thing there.
That would be 10 over 3.
So minus 10 times 6y times 10 over 3y squared. What's 3y squared times 0 equal to? This part is first down here.
0.
Yeah, so we forget about it. I need to take 10 times 6 times 10 divided by 3. What's 6 divided by 3? So that's 10 times 2 times 10. You have negative 200y over y squared. Divided by 3y squared. See on that so far? How do you want to keep simplifying? What's 3y squared squared? Let's just maybe just simplify that.
That would be 9y to 4.
Sure. Have you say multiply everything by y squared? Let's do that. Now, One last.
By the y. I have a poet, I think, but I can really think. So at this point,
Yes, now we just gotta keep simplifying.
I just don't know what to
Take
do.
10 times 6 times 10 divided by 3. Yeah, let's do this. What is 6 divided by 3?
Yeah.
What's 10 times 2 times 10? So we have negative 200y over y squared divided by 9y to the 4th. I just want to keep simplifying.
Cancel out the y.
Okay, so I can
Okay,
cancel
so-
out one of the y's.
Yeah, one of them.
So now it's negative 200 over y divided by 9y to the 4th.
Then multiply by y.
Yep. So that would be negative 200 over 9y. Do you see how that works?
Yeah.
How about you guys online? How are we coming? Be happy to run through this if you need a little help.
Good.
Okay. Let me kind of work through it. We'll get going. Let's see here. Let's do some first derivatives. So 3y squared dy dx equals 10. So dy dx equals 10 over 3y squared. You guys all use quotient rule. I'm going to try something different because I don't like quotient rule so much. I have a y squared in the denominator. How could I rewrite that? How can I get rid of that y squared in the denominator if I bring it up to the top? It'd be y to not the second power, but the negative second power. And now I can use power rule instead of quotient rule. So the second derivative would be 10 thirds times negative 2y to the negative third times dy dx. Let's see here, 10 thirds times negative 2 over y cubed. How do I take care of the dy dx? What can I plug in for or replace dy dx with? So let's see what we got. 10 times 10 is 100 times negative 2 is negative 200. Three times 3 is 9. Y cubed times y squared is y to the 5th. You could certainly use quotient rule, but I'd rather use power rule or writing a negative exponent first. It's all the same thing. How are we doing now, guys?
Good.
Awesome. Thanks, Lily. Then let's do this. I'll stop the recording and let's finish up the practice